Hey, I'm back. So in this second video, I want to go over the formula for tea. So that would be the tea test, not tea, the drink. But before I do that, I saw that I have a misspelling, so let me fix that real quick. That should be number. All right, so now let's look at the formula for the tea test. As I mentioned in the previous video, we will not concern ourselves with the formula because we have software for that purpose. It'll just do the work for us. However, it is still useful to think about what's going on in the formula. So that's what this video is going to be about. In the numerator, we have the means of the two groups, and we're subtracting the mean from group 2 from group 1. And then in the denominator, we have the sigma, which would be the standard deviation divided by the sample size. We add those and then take the square root. Now, the standard deviation would be how the amount of spread. And so what we're doing is we're dividing the means from the amount of spreadness. Is that a word? And so, yeah, let's just move on to the next page. So let's look at the numerator again. What does it mean when the numerator is large? So when you subtract the means of the two groups, what does it mean when the numerator is large? Well, it means that there's a big difference between the two means. Let me type that here. Big difference between the two means. Or I should say, there's a big difference between the two means. And then what happens to t when the numerator is large? Well, mathematically, if you think about fractions, well, the bigger the numerator, in this case, the bigger the result will be, the bigger the t will be. So let's say that t gets larger. Okay, now let's look at the denominator. What does it mean when the denominator is large? Well, that means the variances for the two groups are large. The distribution of the two groups are spread out. And there is more chance for the distributions of the two groups to overlap. Now, okay, great. What does that mean? Well, let me illustrate. We have two graphs on this page, and the top one shows the distribution for two groups when we have large variances. So group 1, there's large variance, so it's really spread out. And then the same for the other group. And when we have large variances like this, there's more of a chance that there will be overlap. And then for the second graph, here at the bottom, the variances of the two groups are smaller. And looking at this, you can see that there's not much overlap. So what this means is that this group here on the left, well, a lot of them are the same or, within the second group. So really, we might even say you can't tell the difference between the two groups versus the one at the bottom. There's very little overlap, so you might be able to say that, yeah, there's not much overlap. So let's summarize that. When there's little overlap, it means the two groups differ in the population. All right, so next question. what happens to t when variance in the sample is large? So when we have a large denominator. So think about fractions again. The larger the denominator, the smaller the result will be. So we get a smaller t. Or we'll put it this way. T gets smaller. And then when do we have a negative value for t? Well, look at the formula here. When the mean of the second sample is bigger, then yeah, you're going to get a negative value. So when the second sample size this mean, wait, when the second sample's mean is larger, and then that would just be the opposite. When do we have a positive value? Well, when the first sample's mean is larger. Now, as it turns out though, whether we have a negative or positive value for t is arbitrary because it just depends on what we define to be the first group and the second group. So it doesn't matter. And you'll see that, or you'll see why in the next video.